Now the next important thing we need to understand about the OSPF is the concept of areas. Now what is areas? Now in this section what we'll see is we'll see what is the concept of areas and then why we need an areas and areas concept and how what are the different kinds of rules when you are designing the network into areas. So the major thing what we have seen in the previous session, like in the OSPF stages process, where we have seen all the routers are going to maintain the same database. That's one of the thing you need to know. That's what we have seen in the previous session, where every router is going to maintain each and every possible route information for each and every destination. But that is a major problem in OSPF, and especially if you are running a very big size networks. I got my head office here connecting to some branch offices and then connecting to small branch offices. Let me take down somewhat easy diagram here. So let's say I got a head office connecting to some of the branch offices, and then again in turn these branch offices are connecting to most of the branch offices again here. So something like this. Let's assume that we got some branch offices here, and similar way here as well. So I got a very big network. Let's say assume that I got some 200 plus routers connecting in my network. Now in case of OSPF, the more bigger the network you have, the more general issues come across in case of OSPF. Now what are those issues generally? Now one of the first issue will be like all the routers especially come with these small routers. Now these small routers, what happens here is these small routers are typically your 1700, 1800 series routers, mostly your access level series routers, which do not have enough memory and enough processing capabilities. Now these routers is running out of memory, because now the condition what we have seen, what we have discussed in our previous cases is, if you just get back, all the routers maintain the same database. Now which means now whatever the database maintained by these small routers, your small routers, is going to be the same what these distribution routers are going to maintain and the core routers are going to maintain. So most likely these core routers do not have an issue maintaining such a big database, because they have enough processing and memory capabilities, and so distribution layer also might be they can easily manage that. But the problem comes with the small routers, your access level routers. They are going to say that probably these routers will face an issue that they say I'm running out of memory. So that's what they will say. You can see here it says my routing table and my database table is too big and I'm running out of memory. I don't have enough resources to process them. And if your router is not having enough resources, so it can reboot most of the times, or it can go down. And if that happens, in that case we will not see the communication generally happen. So we don't want this kind of issues. So this general problem we have, your database table or your majorly your database table, that these routers do not have enough memory capabilities to maintain such a big database table, especially in your big networks. And these routers, distribution level routers, also will face some problems like SPF is running too many algorithms. So the major problem with these routers here will be, they say that my algorithm runs too many times. Now this router says that because normally what happens is whenever there is a change, it's going to update all the routers. Which means, let's say there is a new network is added here. Now who will come to know first? The neighbor router. And what this router will do, he says there is a change, update. It's going to update all the routers, so that all the routers can update their own database. And then to this router, it's going to update database, and then this router to this router, and then to this router, and then to everyone. So whenever there is a small change is happening, like maybe the interface goes down, maybe the new router is added, or maybe the router is rebooted, it's going to send an update to each and every router to update the database, because they must have the synchronized database on all the routers. So each time there is a change in the network, it's going to send the update, which means it's going to run the algorithm also too many times. So it says I'm receiving too many advertisements. That is one of the problem here. And also the core routers also can come across the issue like it says I'm running too many algorithms. because every time there is a change in the database, change in the best routes, it has to run some algorithms and then recalculate the best routes. That's something what generally happens in case of big networks with OSPF. Now these are some of the general problems what OSPF faces when it comes to big size networks. Okay, so that's what you can see here. It says that mostly these routers says I'm receiving too many LSS, link state advertisements, and the core router says my SPF algorithm is running too many times. So okay, and then the access level routers do not have enough memory capabilities to maintain such a big table, a database or routing tables. So what's the solution for this? Now this is the problem and we need a solution to fix this. And the solution is the concept of OSPF areas. So there is a concept of OSPF areas where we are going to group logically these routers into one group. And then this is also one group, something like this. Now what is the benefit we get in grouping the areas? Now grouping is nothing but it's a logical grouping where we combine multiple routers into one group and we give some numbers like area 10, area 20, area 30 and then area 0. I'll come to this numbering again. Now what is the advantage we get? The major advantage is we are going to solve all the problems what we have just discussed. Now if you remember what we have discussed is all the routers are going to maintain the same database, right? That's what we have discussed. All the routers are going to maintain the same database, but it will be within the area. Which means now this router is going to maintain the database of only the routers within the same area, but not the other area databases. So which means the first problem is solved. So the database is reduced, the size of the database is reduced because it is now made within specific area only, and these routers, they don't maintain anything other area informations. So the first problem is solved, and the next problem is was like any change happens, it's going to update all the routers, right? Now if any change happens in this area, let's say the new network is added, the router will ensure that they advertise to all the routers within the same area, and all the routers within the area will participate in the algorithm. So they only participate in the algorithm, and also the advertisement is sent within the same area and it's not going to disturb the other areas. Okay, and then whatever the final change or the best routes will be exchanged outside the area. So which means the other area routers, they are not participating in the algorithm, they are not receiving any advertisements whenever there is a change. So that's something what areas is going to help us. So areas helps in minimizing or reducing these problems, we can say. It minimizes the size of the database by just making it within the specific area, and it's going to restrict the changes within the area only. Any changes happens, it will go within the same area, and the routers within the same area only will participate in the algorithm without disturbing the other areas. So OSPF hierarchical design, that's what we call as areas concept, is going to solve the problem of this one. But again, there are some conditions we need to follow. Like the condition is, let me discuss the conditions. Let's take an example. These are the routers, and Cisco recommends not to use more than 40 to 50 routers in one area. Okay, that's something generally we follow as per the recommendation, not to use more than 40 50 routers in single area. So which means if you have 200 plus routers, it's recommended to have at least 3 to 4 areas. So here I'm making 4 areas here. Okay, that's the first condition we need to follow. And the next condition is we need to ensure that area 0 should be at the center. Area 0 should be the backbone area. So when you are giving some numbering, we can give any number from 1 to, I think, somewhere a big number. We can give any number from 0 here. In fact, we can start from 0. But area 0 should be the backbone. We can give any number like 1, 2, 3 or 10, 20, 30, whatever the numbers. Okay, so we can give the area numbers, but the condition is if area 1 in this, now area 0 will be referred as a backbone area. We call it as a backbone area. 0, whatever the area 0 we call as backbone area, and then the remaining areas we call them as non-backbone areas. Non-backbone means other than backbone. Now these non-backbone areas, they cannot communicate directly with each other. They cannot communicate with each other because if area 1 router, this router, want to talk to this router, you cannot say that there is a short route, I will go from here directly. You cannot. You have to go via area 0. So the transit should be area 0, which means area 0 should be at the backbone or it should be a transit. So all the non-backbone areas, they should communicate with each other only via area 0. So there's a mandatory rule we need to follow. So area 0 should be at the backbone. So when you're designing, these are the mandatory rules we need to keep in mind when you're designing. So area 0 should be the transit or backbone, we can say. There's a one more rule we need to follow. And the third rule is like, there must be at least one area border router. There must be some one area border router. Now in this router referred as ABR, area border router. Now why we call it as area border router? Because this router is going to be a member of more than one area. Like you can see this area as well as this area. And this router is responsible for exchanging the routes from one area to another area. And this router is responsible for participating in the algorithm of both areas. And also it's going to maintain the database of both areas. And then this router is responsible for exchanging the routes between the two areas. Now there must be at least one area border router as per the design, mandatory, at least one, or you can have more than one also. I can say 1 plus. You can have more than one also, but minimum you must have at least one area border router. Like here also I got this router is area border router and this router is area border router, which belongs to both the areas generally. So the router which belongs to both the areas or connecting on the border, we call it as area border router. You must have at least one area border router. So there's a one more rule we need to follow. Like here you can see, I got the same rules here. Area is a logical grouping of the routers. That's what I discussed, and recommended not to use more than 40 to 50 routers in one single area. And all the routers must maintain the same database, but it will be within the area. And any changes is going to impact only the routers within the same area. Now the rules which we discussed just now, area 0 should be the backbone area, which means if I'm designing any areas, I need to ensure that area 0 should be at the backbone. And if I design anything, something like this, area 30, which is not connecting to the backbone here, this area will not receive the routes. Also, the other area routes will not come here. So it's almost like nothing. If you don't design as per the rules. There should be at least one area border router. And there's one more rule when you're designing, ensure that the interfaces facing these two must be in the same area. There's something more on this we'll see when we come to the lab, practical implementation. So these are the mandatory things we need to keep in mind when we are designing the areas. So let us just discuss some of the advantages of the OSPF. Now OSPF, it's a standard protocol, no hop limitations, loop free, faster convergence. Like by default it will take somewhere around 40 seconds. I got some information, I think I missed some of the few points. If you just get back, so it's going to use 224.0.0.5 for sending in updates. It's a faster convergence protocol. By default it is going to send hello packets for every 10 seconds, and if there is no hello for 40 seconds it will start calculating the alternate route, and the updates will be sent only whenever there is a change. So those are the features of OSPF. And then finally we'll discuss some of the advantages and disadvantages, like no hop limitations, low free protocol, and faster convergence. So but the major disadvantage is it utilizes more resources for maintaining the database and for maintaining a linked state information of each and every possible route. So we need to have a proper designing. So even the designing is a little bit complicated here. It supports equal cost load balancing. It's not a big disadvantage, but EHRP supports unequal cost also. and it doesn't support IPX, these kind of things. Anyway, we don't use them, so I cannot say that this is a big disadvantage, we can say. And this is also not a big disadvantage, but the main disadvantage with the OSPF is it's a little bit more complex to configure, complex to design, implement it, and uses some of the more CPU resources in maintaining the database generally.